What about it? 1's 3, 1's 2. What about it? What does that mean? How do we get to 2? In math, how do we start from 3 and get to 2? Subtract what? Subtract 1. Okay? So using that, we have negative 4x squared. And it gives me 8x. We have 2. What's this exponent here? If there's no exponent, what's the understood exponent? 1. So, is this subtracting? No, yes? What do we notice about the coefficient? What is this coefficient? Thank you. What's this coefficient? 3. How can we get 3? From here to here, how can we get 3? What operation will get me from 1 to 3? Multiply by what? Okay, multiply what? 3 and 1, okay. Where do I see a 3 and 1 here? Where's the 3 and a 1? It's not a trick question. Where is the 1? What is that called? Anybody? Okay, what's the 3 called in math? Jesus, what's the 3 called in math? Yes, it's cubed. Well, what if there's any number there? What's it called? Exponent. Good. What is the number in front of the variable always called? Andina, do you know? Starts with a C. Coefficient. So what do we notice between the coefficient and the exponent in your final answer? Okay, if you can't see it there, what do we notice between the coefficient and the exponent in the final answer? What are you multiplying? Okay, so we're seeing that there's a multiplication between the coefficient and the exponent, and then what happens to the exponent? Bro. What happens to the exponent? We already said it. What happens to the exponent? What happens to the exponent? What happens to the exponent? We've said it a million times. Brianna, what happens to the exponent? It does not cancel because there's still an exponent. Donna, what happens to the exponent? Tinoch, what happens to the exponent? Seniors. From 3 to 2. How do we get from 3 to 2? Can we say it louder? Subtract what? This is not funny. How do we get from 3 to 2? Subtract what? Subtract what? By 1, we subtract 1. Jeez, that was like pulling teeth. Take out your notes. God help me. Mr. Esquivel, what are we going to do with this class? Brian, go. Okay. Today is, I'm gonna have to like cut out that whole first part of that video. All right, ladies and gentlemen, today is the 27th. We are at a new unit. Today we're going to be talking about introduction to derivatives. Miss Santana, what's a derivative? Great, I'm going to give you the vocab right now. A derivative is the final answer. Oops, I almost put D twice. The final answer or equation after applying the difference quotient. I know that we were also calling it the instantaneous rate of change. So, Jesus, instantaneous rate of change. Okay. But we're going to call this the derivative from now on. So whenever I ask you for the derivative, you know that you're going to give me an equation at the end that will look like if you did the difference quotient. Like I said, the difference quotient, if you were to use it on those very hard examples, it would take forever to write it. Yes, I had to do it in college, because we needed to find a pattern on how to create the following rules. Before I do that, though, let me give you some notation. The first notation we have is d dx. We say that's d by dx. This means to find the derivative. Then we have notation that we will attach to the final answer. Just like we were putting y equals for the tangent or f of x equals for tangent, we're going to be using this for the final answer notation. So if we start out by using y equals, we have two of the following notations for derivatives. So derivative notation is as follows, derivative. We have dy by dx or y prime. Can I go down? Yes, no? Good? Okay. And this is dy dx. So this is if we start with y equals, t equals, s equals. We have to make sure that we're using these specific rules or notations, sorry. If you start with f of x, that notation is f prime of x. Again, it could be G, H, I, J, K. Does not matter. Whatever the notation is that you start with, if it's function notation or equation notation, they each have their specific notations. Leilani. You need a break?
Huh?
You need a break? Okay. How many more minutes do we need? Maybe like one, seniors? Sam, let me know when you're ready. Diego, let me know when you're ready. Uriel, you're still writing? Jesus, you're still writing? No? Okay. Andina, is your group done? Okay. Ready? Okay. Alright, let me unfreeze this. Where's my... Okay, so let's move on now to the actual rules. Okay? These are the first rules that we'll be using for derivatives. Okay. The first rule that we have is called the constant rule. Does anybody remember what a constant is? In math. What is a constant? Do we remember? This class is always quiet until I let you work in pairs and then you won't shut up. What is a constant? Any ideas? Yes, but in math. Thank you, Leilani. A constant in math is a number without. Anybody remember what it's without? A variable. That is a constant. The constant rule says that if I have d by dx of some constant, c is the constant, the derivative is 0. So if I have 6, 7, 12, that long number on the back of the paper, that is a constant because it doesn't have a variable, which means that when you take the derivative, it's 0. Thank you, ma'am. The next one we have is called the power rule. This is called the power rule because we're going to be working with powers, meaning that we're going to be working with exponents. So the power rule says that if I have d by dx of a x to the n, where a is a coefficient, I can't spell, I'm just going to abbreviate it, and n is the exponent, the rule tells me, let me write it over here. The rule tells me that what I would do is I multiply the exponent and coefficient, and I subtract 1 from the exponent. This is what I was trying to get you to see, is that you multiply those two things. Kimberly was kind of on the right track. And then you subtract 1 from the exponent. But Miss Santana, what happens if we have more than one thing? So if we end up having more than one thing, so let's say we have the function f of x is equal to g of x plus h of x, da da da. Oh, sorry. Can I go down? Okay. Multiple terms. So g of x and h of x are going to be like x cubed plus 7x squared, whatever. What you can do then is, and this is the fundamental idea in the power rule, is that you can then take the derivative of each of the problems or each of the terms separately and put them together. Okay? Brent. All right, some other quick notes. If we have x by itself, what is the coefficient? And what is the exponent? What is the coefficient of x? What is the understood coefficient? 1. Very good. So if there is no coefficient, the understood coefficient is 1. If there's no exponent, what is the understood exponent? 1. Okay? Now, what is x to the 0? What is anything to the 0 power? Not 0. Anything to the 0 power will be 1. So when you see this, you're just going to drop the x to the 0 power, and you'll see when I get there. Okay? Yes, I know this is a lot right now, but we need all of this information to do the problems. For Brian? We have a few more rules that we need to talk about before we do our practice examples. I'm saying, not practice examples, our examples. Anybody still ready? Are we good? Okay. We need some exponent rules and laws of exponents. Okay. So this is a review exponent. I can't spell today. Exponent rules. Okay. So the first exponent rule that we have is the multiplication rule. Multiplication rule. The multiplication rule says that if we have two of the same variable being multiplied together, I can add the exponents. So if this was x to the 4th times x squared, I can get x to the 4 plus 2, which is x to the 6th. The division rule says, if I have them now divided by each other, I subtract. So for example, if I have x to the 4th over x squared, I can subtract the two exponents, and I will get 2. And the last rule is more of a fraction rule. Mr. Esquivel, can you pass out the examples? Yeah. The fraction rule says if I have a function,
This one?
yeah. Can I go down? Like right here. Can I go right here? Okay. That's good? Okay. My fraction rule says that because I have a term in the denominator, I can now use that term and split up the fraction. Let me show you what I mean. So it's going to be x to the m over x plus x to the r over x. Because when you have a divisor, you divide everything by the everything by the denominator in the numerator. Okay. When you're done with that, take out the sheet that Mr. Esquivel is passing out. We're going to work on some examples. We're going to go back and forth, guys, okay? We're going to do an example, you're going to do practice. We're going to do example, you're going to do practice. Oh, excuse me. Okay. Are we ready? Ready? No? Everybody's done writing? Okay. All right, let's look at the function. We have f of x equals x to the 7th minus 9x squared plus 15. The directions ask me to find the derivative for the problems and make sure to use correct notation. So this is function notation, which means that I'm going to have to use the function notation that I gave you for derivatives. So it's going to be f prime of x. Any questions on that part? It's not a 1, it's a prime. Okay? Are there any questions? Are we sure?
Yes.
Okay. Now I'm going to use the power rule. Remember the power rule says I'm going to take the coefficient, multiply by the exponent, and subtract 1 from the exponent. Okay? What is the understood coefficient here? Right here. 1. Okay? Now I'm going to apply the rule. I am going to multiply my coefficient times my exponent. 1 times 7. Questions on that? Then I'm going to subtract 1 from the exponent. 7 minus 1. Are there any questions on that? Are we sure?
You said 7 minus
Yeah. I'm just following the rule. So n is 7, so I'm doing 7 minus 1.
Oh.
That makes sense?
Yeah.
Okay. Now I'm going to do the next one. 9 times 2. See that? Coefficient and exponent. X to the 2 minus 1. Questions so far? Are we sure? Okay. This is called a what? 15 is called what? I see some people mumbling and mouthing it. It's a constant. What is the derivative of a constant? What is the answer for a derivative for a constant? I see some of us looking back at our notes. Now I see more people looking back at our notes. What is the derivative of a constant? It was the first derivative rule I gave you. Hmm? I don't think you... Do you have that one down? La Rochelle? It's 0. The derivative of a constant is 0. Always. Okay? And now you simplify it. So we have f prime of x is equal to 7x to the 6th. Are there any questions on where I'm getting that? Minus 18x to the 1st. And because it's plus 0, I don't need that there. Are there any questions? Are we sure? All right, then flip over, and I want you to do the first one with your group. Like 3 minutes. You can talk to each other. Lenani. Yeah. Seniors, some of us are not trying, you're just staring off into space waiting for the answer. You need to try. Just keep the sign in front. No. That one. 2 minutes. All right. Some of us are done, some of us are still not working, so let's show the answer and the work. So the final answer was 9x to the 8th minus 12x squared plus 5. The first term, I multiplied the coefficient times the exponent and subtracted 1. Coefficient times exponent, subtract 1. Coefficient times exponent, subtract 1. Derivative of a constant is 0. Are there any questions? Ladies? Gentlemen? No questions? Are we sure? Then I'm just simplifying. 1 times 9 is 9. 4 times 3 is 12. And then the exponents, 8, 2, and 0. And because I have x to the 0, I can just drop it, and it just becomes plus 5. Questions? Snaps if we got it, hands if we need help. Nobody? Thank you. What's up?
No.
You put your hand up.
No, I didn't.
Okay. Questions? All right. Well, I'm not going to do example 2. It's the same thing, just with fractions. But I will do example 3. We have y equals 9x to the 7th, 7 over 2x squared plus 10x to the 4th over 5x cubed. Okay, here we have to use our exponent rules. So before I start taking the derivative, I need to simplify the exponent. So using my exponent rules, I know that this is division. Division means that I'm going to subtract the two exponents, but keep the coefficient the same. Are there any questions? For division, you subtract the exponents. So multiplication is adding the exponents and division is subtracting. I can show you later exactly why. Okay? And then I do the same here. Plus 10 over 5. X to the 4 minus 3. Now, a lot of students will think as soon as they finish simplifying this, they're done. No, you just rewrote it to make it easier for you to find the derivative. So let's simplify it. We have 9/2, x to the 5th. Are there any questions on how I got that? Questions on how I got that? Are we sure? Okay. Plus 10 divided by 5 is 2, x to the 1st. What's wrong?
Why don't you just divide it down with the 2 first?
Because this is a simplified fraction already. I can simplify 10 over 5. Remember, I want simplified fractions. Unless I tell you to use decimals. Always simplified fractions. Okay? Again, a lot of students will stop here. No, you need to keep going. This is just you rewriting it. So I will apply the rule. Again, coefficient times exponent. Subtract 1 from the exponent. Brian, you writing this down? Plus coefficient times exponent. Subtract 1 from the exponent. Power rule is always that way. Multiply, subtract. Multiply, subtract. So then simplifying, I have dy dx is equal to 45 over 2, x to the 4th, plus 2x to the 0. And then I just simplify it a little more. 45 over 2, x to the 4th, plus 2. Questions? Questions? Sorry, let me give you processing time. Oops, sorry.